Hello and welcome guys to Get channel. Today we are going to discuss about conflict equivalent schedules. Now, what is conflict equivalent schedules? We are discussing this concept after understanding what is conflict serializability. So I recommend you to watch my previous lecture. Now we are discussing about conflict equivalence. Now there is a two transactions T1 and T2 here. There is another two transactions T1 and T2 here. Now we need to check, we need to draw precedence graph for these transactions. I am taking T1 here, I am taking T2 here. What I told you is first take this read of P item and look downwards, go downwards. Read P and write P. What is the rule of conflict serializability? They should operate on same data item, there should be different transactions, at least one write should be there. So there is a conflict between these two transactions here. So T1 to T2 I am writing a conflict in this way. Check whether T1 to T2 is there, no. And T2 to T1 is there or not. T2 to T1 it is not there, right? P is there, P is not there in this T1. So if you go downward also you can't find it. You check T1 to T2, again you find that T1 to T2 is here because R is there in both of these one and read of R is there, write of R is there. Both are different transactions. So there is a conflict here between read and write. We need to check downward only. Remember that we need to check downward only. So another arrow is not required. So this is the precedence graph. Now draw precedence graph for this one also, this schedule. You see read P is there, write P is there. Arrow should be downward from read P to write P. There is a conflict. Now T1 to T2, arrow should be like this. Is there any arrow coming from T2 to T1? Now check that one also. Write P is there, check another write P or read P in this T1. You can't find anything else, right? Now you check T1 here, read of Z is there. Check for any of the read or write item of Z in this one. You can't find it. Any write item of Z is there? No. Read is there and again read is there. What I told you, at least one write should be there. So there is no conflict here also. There is no conflict here also. Write read is there, but data item is different. Here R, here is Q. So T1, T2. Here also precedence graph is T1 to T2. So both precedence graphs were same. So what can we say? These two schedules are conflict equivalent. Note it down. Look at this question. This is a schedule and this is another schedule. We need to check whether these two schedules are conflict equivalent or not. Now first I am taking this schedule. We need to draw precedence graph for this schedule. So I am taking T1 here, I am taking T2 here, I am taking T3 here. Check from first read of A item and then you go down. You go from top to bottom approach. Read, at least one write should be there. So this is not a conflict here. Read, at least one write should be there. This is not a conflict here. Read, write is there. Different transactions were there. But this is data item A, this is data item B. So there is no conflict again here. Read of A is there. Write of A is there here. Different transactions were there. T1, T3 are different transactions. This is read item, this is write item. Data item is same. So there is a conflict from T1 to T3. You should draw it like this. Now check from T1 to T2 again. Read. So no conflict is there. Check from T2 to T3. This is read B. This is read B. So no conflict. This is read B. Write A is there. Different data item is there. A and B. So again no conflict is there. Now you check write of B with this A, with this one. Write of A, no conflict is there. Write of B, no conflict is there. When you take this one T3, read B is there, write B is there. First one we got like this one. Now read B, write B, we are getting like this. So T3 to T2, another one we should draw. Is there anything that is from T1 to T2 or T2 to T1? You can say that T2 to T1. Is there any something like that? T2 to T1. This is right, so not possible. So nothing is there. So this is the precedence graph. From this precedence graph, we can say that the schedule was like this. Means what does this says? This says that this congruent schedule gives the same output as serial schedules run in this manner, T1 after T3 after T2. The output of this execution is similar in the way of output of this congruent schedule. Now look at this question. Look at this schedule now. This is read A, this is write A. Both are different transactions, T1 and T2. One write is there, same data item is there. So while drawing the precedence graph, this is T1, this is T2, and this is T3. First we need to go from T1 to T3, T1 to T2. There is a arrow you should draw like this. Now check from T2 to T3, something is there or not. T2, write of A, read of B. Because data item is different, A and B, so this is not a conflict. And write of B, read of B. T2 to T1, another thing we are getting here. Now check another thing also, read of A to something like this. Read of A to write of A is there, read of A to read of B is there, read of A to B is there. So we can say that without T3 also, T1 to T2 there is a cycle. Cycle is there. So what can we say from this one? Because there is cycle, this precedence graph says that this schedule is not conflict serializable. I can write it here. This schedule is not conflict serializable. Because this schedule is not conflict serializable, we can't check whether it is conflict equivalent with some other schedule or not. For checking conflict equivalence, it should be conflict serializable. As I told in my previous lecture, if there is any cycle in precedence graph of a relation of a schedule, then we say that that schedule is not conflict serializable. So we say that this is not conflict serializable, but this is conflict serializable. So we can say that these two schedules are not conflict equivalent. From these two examples, I hope you understood what is conflict equivalence between two schedules. Now note it down, and thanks for watching this lecture.